Okay, so today we're just going to go over some basics of exponents and logarithms. So let's start with just understanding the properties of exponents. So if you are going to, and this is best just with examples. I know that a lot of examples on these notes, but it kind of helps to just see. So if I have something like 4x squared times x to the third, if the base is the same in a problem, and you're multiplying those exponents, then you can add the exponents together and combine them into 1. So this would be 4x to the fifth. Now when I see this, what I think of is this x squared means x times x. And the x cubed means x times x times x. And if you look at it visually like this, you can see that this actually is 4x to the fifth power. And that's kind of how I try and separate it out in my head. Now, if you have the same thing, let's say you have 4x squared plus x cubed, this cannot be simplified. That's as far as it can be simplified. So remember, this is just with multiplication. And separating out multiplication and addition is one of the biggest battles that I see. It's like, okay, what are we doing with multiplying versus adding? So adding, you can only combine like terms. Multiplying, you can multiply anything together. They'll just kind of sit next to each other. Okay, so then what happens is that you sometimes get negative values in there. So if I have 4x, actually let's do a different number, sorry, I'm stuck on 4 here, 5x squared y cubed times 3x to the negative 4 y squared. Okay, so this starts to look really messy. Well, you can multiply anything together. As long as there's no addition or subtraction in there, you can multiply it together and you can move things around. So you can take these same terms and move them next to each other. So 5 times 3, this is what they mean when they say multiplication is commutative. It means that you can move things around. Let's put the x squared here, the x times x to the negative fourth, times y cubed times y squared. So all I did so far is just move things around so that everything is by everything's by the ones that are like each other. So then we can multiply the 5 and the 3. And here then you can take and multiply these two together by adding their exponents. Now this is negative, which means that this is actually the same thing as 1 over x to the fourth is another way to just remember. We talked about that earlier. But when you add them, it's okay as long as you follow the rule, you'll still get x to the negative 2. Because there's 2 on top and 4 on the bottom, so you're left with just the 2 on the bottom. And then you have y to the third times y squared gives us y to the fifth. Now when you write your answers, you never want negative exponents in your answer. So we would then take 15 y to the fifth, and that would be divided by our x squared. To make it a positive exponent, you would move it down. Okay, so a negative exponent becomes positive if you move it into the denominator. Okay, all right, so then you also have a little bit different rule if the exponent is on the outside of the parentheses. Oh, and just really quickly, there's one other thing I wanted to mention. If you take x times x cubed, it is implied that this has a power of 1, so when you multiply those together, you do get x to the fourth. So just remember that this, if there's nothing there, it does mean 1. Okay, so now what about if this is outside the parentheses? We have to take and you have to distribute your exponent into everything inside of here. So it has to be, you have to square your 3, the x to the fourth, and the y. So what you're going to end up with is 3 squared times x to the fourth times 4. So it'll actually be x to the 8th. So you're multiplying them instead of adding them. And then here the 1 times the 2 gives you 2. So it gets a little bit tricky, and then we'll do 3 squared, which is 9. So you'll get 9x to the 8th power and y squared. Now this is why we're reviewing this. When you multiply, you add the exponents. When you add, they're only like terms. When you square, it becomes multiplication. Okay, so then you are multiplying it into the exponents, where here you'll be adding the exponents. So that's the separation you'll make during the lesson, is the difference between the two. Okay. Now, when you have, and then just going back to those negative exponents, if you have exponents on the top and the bottom of a function, and we went over this a little bit earlier, you can take, and let's say this is -2. You can make any exponent, and let's put one down here, y to the -1. If you move it from top to bottom or bottom to top, it does make it go positive. So for instance here, if we want to make this positive, you can move this up and it becomes a positive y to the first power. And I'm going to show you though, I am going to move everything up to the top on these problems. To me, this is one way to do it. There's multiple ways. I'm going to move the x to the 5th up to become x to the -5th. And so now everything is in the numerator. The reason is then you don't have to worry about memorizing what to do when you're dividing. You're back to a multiplication problem that we've already done. So by manipulating it, you're skipping over the mistakes that happen from switching back and forth. Now, if you've learned that you can subtract these exponents and you do it efficiently and accurately where you're getting the right answer every time, then that's just fine. But this is another way that I've decided I like better. So I take 3 and I multiply now x times x to the -5, so I add their exponents. Remember, this doesn't have anything, so it implies that there's a 1 there. So 1 plus -5 gives me 3 to the, x to the -4. And then here, now we're going to look at the y values, and we have y squared plus, so -2 plus -5 gives me y to the -7. Now we go through and we make sure that all of our exponents are positive. Now to make them positive, we switch them either from the numerator to the denominator or likewise to change the sign of the exponent. And it only takes what's immediately with it. Okay, so like this to the -4 is only affecting the x. It does not affect the 3. So then we have x to the +4, and then this will come down as well, the y to the +7. Okay, so just kind of working with those exponents. Now, when we start working with exponents and solving problems with exponents, it's also important to know that when you solve, so if you have something like this, 4 to the -2k equals 16, we can solve this using logarithms, but some of these, if you get the same base, it makes it so that you have, you can set the exponents equal to each other. So let me show you. Here, if we take 4 to the -2 and say, well, I know that 16 is the same thing as 4 squared. Okay, so using exponents, we've manipulated this so that we have a base of 4. If you have something like this, the exponents have to equal each other because otherwise this equal sign would not hold up. So if you have 4 raised to -2k and 4 raised to 2, therefore -2k has to equal 2 for this equation to be true. And then that eliminates the exponent part of the problem and we're able to just solve for k. By dividing both sides by -2, we get k equals -1. Okay, now this is something that you probably did before, and like I said, this is a fast review because I'm assuming you know these things. If you don't, then we'll talk about that, and I will give more practice and more time, and we'll work on it that way. Okay, so so you can, for instance here, if I have, and there'll be harder ones on the assignment as well. These are just easier ones to start out, and then I like to have the harder ones, go through them in class and talk through them and let you ask questions. If they already have the same base, then you can set your exponents equal to each other and solve for x. So here, then we would subtract 3x from both sides, or vice versa, we can subtract a 1x from both sides here. Just because then here we'll have, it'll just skip one step. -3 equals 2x, and then we would solve for x by dividing by 2 on both sides. And we know that x then equals -3/2. Okay, so like I said, quick review. Okay, so now let's take and look now at how logs and exponents, how they coordinate with each other, how you can take something in a logarithmic form and change it to an exponential form. Okay, so we take our log, let me say I give you a log. Log base 11 r equals -1, and I say write this as an exponent. Okay, well, logs and exponential functions are inverses of each other. But it really helps us to solve problems if we use that property. So here we take the base of your log. The base of your log becomes the base of your exponent. And then you take your answer, becomes your exponent, and this part becomes your answer. Okay, so it's kind of like you swap. You take the base becomes the base of the exponent, and then you swap these two so that now this number is in relationship to the exponent, and this number would be, that's with the log, would become the answer. Okay, so it's kind of just getting used to that swapping. So let's do another one. Log of 5, log base 5 of 1 over 4, 1/4, equals -2. Okay, to take the base becomes the base of your exponent, this answer becomes your exponent, and the solution becomes, or the answer of that one becomes 1/4. Okay, so see how, so what I think about is one side is going to be either a log or an exponent, and the other side is just a number that's an answer. So make sure that whatever number, this base becomes the base, and then whatever number is here, if it's associated with the log on this side, then on the exponential, it'll be on the other side by itself. Okay, so they kind of swap sides. Likewise, you can take an exponential and you can change it back to a log. So if I have 13 raised to the second power equals 169. Then to change this to a log, I would take the base of my exponent becomes the base of my log, and the 169 would move over here, and we would be left with 2 as my answer over here. Okay, so make sure you can switch between the two, and I'm assuming that's something that you've done before. Okay, now logs work the same way as exponents. If you can get a problem to have a log on both sides that's the same base, then you can eliminate the logs because it has to be equal, that what you're taking the log of has to be equal on both sides. So here, if I have log base 6 of these two, I know because it's the log base 6 of this answer has to equal the log base 6 of this. Because they're equal, if you're going to take log base 6 of the same thing, then those two things have to be equal to each other. Like it wouldn't be an equality sign if not. So then once we get to here, then we've eliminated the logs and we're able to solve for B. Okay, so this is a lot of review. I'm really hoping no one's freaking out right now. But like I said, if you are, you guys are kind of I had my class vote and they wanted exponents and logs reviewed together in one lesson. So we'll see how comfortable you really are with it. And so then we'll have a -2b left when we add 3 to both sides, 3b, which then leaves us with a 5. So b would equal 5. Okay, so that's kind of a fast version of that. Okay, so a lot of that is just super quick review. We'll see how well you know it and see if we want to do another lesson on it.